Hello everyone, this is Joey from Adelaide. Welcome to my second part of the VBA programming tutorial. I always intended to do this tutorial in so slow pace for people who are struggling to follow with VBA programming. Today I'm going to talk about which is subroutine versus function, how you can use them in VBA context. So to get started with Excel VBA programming, the first thing we need to do is open up Excel workbook. Start off with a blank workbook. Go to the developer tab and fire up the Visual Basic editor. From now, you would only see two Microsoft Excel objects. The way I always do it is I will add in a new module. So what's the correlation between the module and the the two object over here? I will in a future video I will demonstrate what are these for, but for the time being, let's just follow along to follow along to understand subroutine and function. So what is exactly subroutine and function? The way I see it is subroutine is sort of like a command for the Excel. Function, whereas function is just a just a a smaller abstraction of your procedure. So you could build a very massive program. For example, here massive program. So I can continue to, let's just pretend this is a code, and I can go on like forever with the code, and that could be maybe 3 or 4 page long. So that is not really advisable. In order to be efficient and to make your code more readable, the best way is to cut your code into a smaller piece. So let's say test 1 and function test 2, for example. So each of these functions encapsulate a certain work that it needs to be done. So why would you want to do that anyway? Why would you want to segregate that into multiple smaller workflow, rather than having it as a gigantic 4 pages long code? The reason is best for any programming as such, right? It is best to use reusable code. What it means is that we try to recycle our code so that it uses the same function. So the other thing as well is this is probably the worst example to name a function. Normally, right, what you should do is you should give a meaningful naming for your function. For example, you would say square I would say not square root, but let's say it's just square. For example, to perform a square, So to perform a square, your function should take in two arguments, or actually not really, just one single argument, to be honest. So let's say a number. It shouldn't be a string. Instead, it should be a integer or long or double. But for the sake of this tutorial, I'll just name it as just use integer as the argument. So what it means is, in this context, is that we have a function which is called square, and we are expecting the argument as an integer over here. So the action of square is we take the number multiplied by its own to get a square. But how do we return that number anyway? So we have to say square equals to number times number, and then we return another integer. So that's it. So you can use this function in your subroutine. So let's say square 5, and then let's just message box it for the time being. So what happened over here is we could do the equation or compute the value over here, and then feed it back to a message box which give you a alert box. So let's just run that. So you can see here, as you can see here, you can see 25. So again, if you have followed my previous videos, I have demonstrated how you could trigger your subroutine from your main workbook, because for the obvious reason, we don't want any user to come here and click this run button every single time. That is really not the best way to present your work. So the way I always do it is I will put a fancy little button over here, and then link it to our subroutine over here. Notice that we can't there's no possible way to see your function over here. So that's why for your trigger for your program that you're going to build for the VBA, so you have to declare a subroutine, and then from the subroutine, you actually trigger from your button. So from a subroutine, you can actually call a square, and in fact, if you follow my previous video, I have demonstrated how you can use different variable type. So in this instance, we can say my result equals to square of 5. And if I want to be a bit fancy than that, I can in fact say the following. I said dimension input as actually input 1 as integer, where input 1 equals to, let's say, 8, for example. And I'll assign input 1 over here as the argument to my function over here. So what it means is that it will make a copy of input 1, and then it will pass it to the square over here, and the square will do the multiplication over here and return it as an in very simple example over here. And we could return our result for the message box, and by the way, message box itself is a function by itself, but this is a built-in function in the Microsoft Excel. So if we go back to our workbook and run it, we will see 64 because it was a square function that does the job over here. And bear in mind, right, I actually didn't declare what result type is supposed to be. And what the VBA is doing it is when it's running it on the runtime, they call it. It is actually knowing how to resolve that to a type, which in this case is integer. So let's just probe it, just to see some sense in here. And as you can see here, it carries a variant slash integer over here. So if you have a very gigantic program, it is best to type your variable. What does I mean by type? My type is not as in typing, but as in the type. So if you have declared a type for your result, for example, the following result as integer, and if we would have probed it, right, so you can see that the type has reserved for integer. This is a much more efficient way of doing a VBA coding if you are not familiar, because you might have a very big program in future where you're storing a lot of data in your memory, and then you might need to do a lot of computation. So having them with their respective known type and storing them as their own reserve type. Or so let's just remove this at the time being. Let's do something else. So this is the a function where it returns a type. You could also have a function that doesn't return a type, because maybe after all you just need to run an action, and maybe it doesn't need to give you back any result. For the most familiar case is the following: write to cell, for example, and then I'll give a cell value. I would say a cell column name, for example. And what I'm going to do is I'm going to do a square, and then I'm going to write it to a cell. Okay, so well, actually I'll call it the result of square. Okay, and then what I'll do is I'll say active sheet dot range A1, which is column A, and row number 1 dot value equals to result of square. And in our subroutine over here, where we, if you remember again, if we click the button from our workbook, this is going to get triggered first. And if you do a square dimension result as integer, and then write to cell, sorry, my bad, result equals to square times 10, for example. And then we'll just say I just want to write to cell with my result. So let's just run that first. Oops. I think I have a misspelling over here. That's why VBA is saying you haven't declared your variable as yet. And let me just go back here and run it again. So as you can see here, 100 is committed to this value over here. So another way to do the same action is we could equally say the same square of 10. Okay, this is a bit advanced, but it's quite simple to digest what it's trying to do. The first thing is you have to look to your function argument first. So what does that mean is that the write to cell is expecting some kind of argument. Okay, so it needs something to be fed into as a argument to this function over here. So, and bear in mind this should be, sorry, this should be an integer rather than a string. Sorry, I've confused you. But what I'm trying to say is that it is expecting some kind of input over here, and the input has to be a computed result. So therefore we look to the right, and square is, it's not a result, it's a function again that takes in a value. So what happened is square 10 would give you 100, and the 100 was eventually passed into this function over here, and when our function is called, it will write the cell value. So what we intend to do is show me the first element. Okay, so here what we do is we say dimension my collection as a variant. So remember, variant is nothing but I would say a free holder over here, but normally I will use it to store collection. So by the way, in case you didn't know about this, we could do the following as well. Oops, sorry. The way to do is the following. So the way to do it is the following. So you put a bracket here to say that this is an collection of integers. Okay, and then if I say my call, actually I need to give a size first. Let's say it has only 1 to 2. In fact, we can be smart and then put it here. Okay, so what does that mean? So what happened here is we have a my colon which has a index 1 to index 2. If we probe that, see here we have two element here which starting from index 1 to index 2, and they are type integer. So what my intention is let's say my call 1 equals to, let's say, 100, and my column number 2 equals to 200, for example. And if we pass that as to our function, okay, we should expect a value of 100. Okay, sorry, we need to fix this first. So if we run this code over here, we should be running from here. We have subscript out of range. Let's debug it. And if I expand that, notice that a column which is passing from here should have index 1 to 2. So I put in 0, which is not a valid number here, because minimally should be 1. And if I run that, so it's 100. So if I change that to ref, okay, what will happen over here? So what I wanted to prove over here, if I mutate a column into 1000, for example, we should see 1000 because we change the collection, the first element of that collection. However, if we actually, right, if we continue to just to probe this, as you can see that has changed to 1000. But if I change that to by value, okay, so funny enough, you get 100 over here. Okay, so you get 100 over here, but somehow remember that we pass in as a argument to this function over here, which supposed to change the first element to 1000, but it is not, you see. So it has preserved this value over here. So why is so? Because by value makes a copy of whatever is in my column, okay, and then it starts the or its computation over here, and then once you get out of the computation, which is by the termination of the end function here, it will just throw away all the memory. So you must be wondering why I need to show you this anyway. So in the programming world, especially if you come from or if you hear from the C++ programmer, this is normally called as the pointer. So by using by reference here, we are effectively pointing it to the same uh, argument or the same variable which is passed in here. So by reference doesn't make a copy. By reference will modify the original variable that was passed in, whereas by value is a safer option in case you just want to do a localized computation and you don't want to change or mutate whatever state is on your main subroutine. And if you encounter a large program, especially in a future video where I will sort of introduce you to the class module, it is quite advisable that you use by reference, because you don't want to store a lump sum of memory in your Excel. And by the way, just to show you another perspective, is you can see Excel. See here, Excel here is currently using about 22.9 megabyte over here. Okay, but if you use a lot of by passing it by value, they call it, you might end up with a very big memory footprint. But that doesn't mean that you are strictly bound to by reference. It also depends on your use case, but I would say for a temporary computation where you need to hold a value for a short while, right? Remember, once it goes out of the end function, you throw that away in your memory. If you need to temporarily hold it for a short while, it's much more advisable to use by value. But if you have a big computation where it needs to hold a bigger collection set, say a 2 by 2 collection, then this would by ref would make much more sense if you need to alter some kind of matrix. You might not see this often in a video tutorial. I've used this trick multiple times. Not sure it makes any sense, but let's have another subroutine called my second sub, for example. And so my second sub is running possibly some kind of function over here. So let's just abstract that away for the time being. So let's call this running my second sub routine. Okay, now what I wanted to say is that you can call your subroutine from another subroutine. Okay, so let's just run that first. Comment that out, or maybe not. Let's just show some sense of this. So if I do that, so you'll show 1000, which is and then I'll get a second pop-up box that says running my second sub. Now you might be wondering, like, why would I want to do that anyway, right? Because I can in fact add another button over here and tie it to my second subroutine. and trigger it from here. No big deal. So the way it works out for me is that I normally try to construct everything in a smaller pieces. So often is I try to build my code using a smaller subroutine and having them with many more buttons. And once I am happy with how the way it runs, I will use a massive big button, which is something like this, to run multiple subroutine. Obviously, with the subroutine, you cannot pass in argument like that, just like the function. So in order to pass in the argument, you need to use the function. Don't use the subroutine. But the subroutine, right? The way I use it is that if they are independent of each other, so they don't share what I call a common memory or a common variable, but you can do a hack on it, which I will show you in in other future videos. But pretty much you can construct a smaller piece, one piece by one piece, and then put a big button to wrap around multiple subroutine. So I hope you enjoy my video. Don't forget to click a like or subscribe. Thank you.